Hi, in this video, I just want to cover over the few things like how we should implement the network with subnetting concepts, IP addresses, and using the routing protocols for the communication between the different subnets, basically. So let's get started. So we'll just take a simple network topology. Let's take PC and let's take a switch. Switch 0 and let's take the empty router here and the same. And another empty router here. And we'll just give one switch over here and here. Okay. So the network devices are completed. So we just need to give the connections. We'll just use the automatic ones. So in the routers, we need to give, like the modules. Let's give the fast Ethernet modules. You can give how many interfaces you want. I'll just give maybe 5 here. And on the router. Repeat the same for all the routers. And the same for the router 2. And for the router 1 as well. And turn it on. Let's check whether, okay, we just gave the other one, so we can delete it and give the fast Ethernet module. And turn it on. Okay, so it's a fast Ethernet. Yes, fast Ethernet and the fast Ethernet. Okay, we have selected the different one here. Let's just change it. You can delete like this. Click on CFE module and just drag it and keep it over there. And turn it on. Okay, that's it. So all the interfaces will comes up when you just click on this router. Now let's work on the connection side. to router 0 to router 1, and this router to this router, and this to this, and this to this, and here to switch to, and switch to end device, and the router 1 to switch 1, and the final part switch 1 to PC1. Okay, so now we need to give the IP addresses to the devices, and so I'll just separate this as one palette. This comes under the same network domain. So yeah, I'll just use the subnetting for these four networks. So usually for 192.168.1.0 for the slash 24, which is nothing but the class C network, 255 IP addresses. That means that 24 for the network bits and 8 for the host bits, basically. And the network mask will be the 255.255.255.0. And to determine the wildcard mask, we generally use it for the routing protocols. We just subtract from 255.255.255.255. So which means for this 0.0.0.255. So we'll just do the subnetting. So here we just need four subnets. So subnetting, we just need four subnets, and to do the subnetting, we just use a formula 2 power n basically. So here it's obvious that the n should be 2. So that means we need to borrow the 2 bits from these addresses, from this IP address. So it leads to 192.168.1.0/26, and each bit contains 64 IP addresses basically. So, and it's clear. And to determine the next subnet range, so the first range is 192.168.1.0/26. So, and to determine the next coming subnet range, we just need to go to the 26th bit, which is generally the network address consists of 8 octets. In the last octet, 26, this would be a 25th position, and this would be the 26th position. So the next range is 64. So 64. And we'll add the same to the next plus 64, which would be the 128, and plus 64, which would be the 192. So the addition of this, all of this will lead to the 255 IP addresses. So that's how we'll determine the subnetting. And the subnet mask will be 255.255.255.192, which is 32 plus 16 plus 8 plus 4 plus 2 plus 1. And this is on the network side. This is for the network bits, and this is for the host bits. And for the wildcard mask, we'll do the same. We'll just subtract from 255.255.255.255, which gives a 0.0.0.63. This is mainly useful for the routing purposes, like when we configure, like OSPF or of any of the routing protocols. So basically, EHERP, RIP. Okay, now let's get started. First, we'll just name the IP addresses here 192.168.1.0/26. We'll just copy this, Control C, and here would be 64 as we discussed before, and this would be 128. And here 192. Okay, so this part is done, this part is done, and this part is done. So, and we also need to mention for each link, so each collision domain basically. So we'll just also do the same for this. Let's give here with I just give go with the /24. So 10.0.1.0/24, and I'll just give here 2.0, and here, okay, let's give 3.0, and here 4.0. Space dot one, two, here, two, dot one, two. Okay, 1, 2, 1, 2, here, 2, 1, 2. Okay, done. So we just given the IP addresses naming. So let's get started to configure it. So to configure the IP address, we need to go to the IP configuration, and here we can configure. So 192.168.1.1. You can give any number in the range. So, and the subnet mask is 192. Okay, we'll just give the default gateway. So it is nothing but the router's FA9/0 IP addresses. So let's give it as 192.168.1.50. So here it's done. And we'll repeat the same for all the pieces. Let's okay, let's do it the same for this PC. 192.168.1.65 and 192, and the default gateway we need to mention in the within the same subnet range, so 64 to 126 basically. So let's give it as 100. This FA fast Ethernet 9/0 IP addresses basically. This part is done, and we'll do the same here for the PC2. So 192.168.1.129 and the subnet mask. with the same 192, and default gateway, let's give it 100. Okay, let's give it 150 range, and PC1. Let's give it 200. So from the PC side, it's done, and we need to configure the IP addresses for each routers. So for the router 1, go to the CLI and enable, and go to the configuration terminal, and we need to go to interface. So let's just configure the FA9/0 first. We'll give the command IP address 192.168.1.50, and the subnet mask is 92. And for each interface, you need to give the command no shutdown. It's shut down by the default. See, it's went to up. And let's go to interface FA8/0, and the IP addresses is 10.0.1.1, and the subnet mask is 255.255.255.0, and no shutdown. Okay, this part is done, and we'll go to FA7/0. IP address is 3.1. And no shutdown. So this will be up when we do the same on other router side. So let's do the same for this router as well. Enable conft interface FA9/0, IP address 192.168.1. We have given 100, the default gateway. So 255.255.255.192. Now shut down. And for the interface, FA7/0, do the same IP address 10.0.3.2, 255.255.255.0. Done. And we need to give the command no shut. And the last interface, FA8/0, IP address, which is of 2.1. No shutdown. So this is done. So we need to do the same for this as well, for this side and for this side, for the routers. So let's go to the router 1 and CLI space. Enable conft. Let's do for the interface FA7/0. IP address 192.168.1.200, 255.255.255.192. No shit. Yeah. And for the interface, let's do it for FA 8/0. IP address 10.0.4.2, 5.255.0. And no shutdown command. Okay, and the last 9/0 IP address is 1.2 and no shit. So the three routers are finished, and if you do for the router 2, then it will be completed. So enable conf-d and let's do it for interface 6/0 fast Ethernet. IP address 1.150, 192, and the command no shutdown. Let's do it for FA 9/0. IP address 10.0.2.2, 255.255.255.0, and no shit. And for the last interface, FA 8/0 IP address, we just need to give 4.1. Okay. And the last command no shutdown. So yeah, everything came up with green here. So we are ready to configure the routes on the routers so the different subnets can communicate with each other. So yeah, everything came to green. Implementation and giving the IP addresses using subnetting is done. So let's dive to the routing protocols. So the main purpose of the routing protocols is like I just mentioned. Okay, this is to check the routing table in the routers basically. You need to give just the command show IP route. So here the router only know the connector networks. So how about if the router wants to reach the packet sending from this network to this network? So the source will be the 192.168.1.0/26, and the destination would be 192.168.1.128. So the router doesn't have any information of this network address in the routing table. So it just dropped the packet. So that's where we'll just give the static routes. So for the router 0, for this router, we need to give the static routes for this network address, and this network address. For the same, this router, we need to mention this one, and this one. And for this router, 1.192, 1.0, 1.64. And for this network, the router, we need to mention the routes 1.192, 1.0, 1.64. So we just mention in the IP route mentioning that to reach this network, you can reach the next stop addresses. So we just mention in that command. So here to give the static route for this router, so we just mention IP route and mentioning two address. So basically 192.168.1.128. And we'll also mention the subnet masks and we'll just give the next stop address, which is 10.0.1.2. So in the router 0, conf d, and we'll just give the IP route. So here we need to mention the three networks IP routes, how to reach. So we'll just give the command IP route 192.168.1.192, 255.255.192. So mentioning also how to reach the network. Let's give it this hop address, which is 10.0.1.2. 10.0.1.2. Okay, this part is done, and we'll also do the same for this network and for this one as well. So for the 64, you can take this router's hop address. So 10.0.3.2. And we'll do the same for 128. For 128, you can take this path, or you can mention this one or this router ID. Okay, this one would be good. So we can mention this router's hop address. So 10.0.1.2. So done. So we just mention the three network addresses static routes in this router. So we'll repeat the same for all the routers. Conf d and route 192.168.1.0, 255.255.255.192, and the next hop address is 10.0.3.1. And for 128, we'll just mention this hop address, interface hop address, which is 10.0.2.2. So we'll mention the same. And we'll also repeat the same for one over the leftover the network address, which is 192. So 192, you can take the path. Okay, we can mention the same. 2.2. Okay, done. And we'll do the same for this router as well. IP route 192.168.1.192, 255.255.255.192. And we'll mention the next hop address, which is 10.0.4.2. And do it for the 64. Okay, for the 64, you can take this path. So we can mention the next hop address is the interface, which would be the IP address is 10.0.2.1. And the last 1.0. Yeah, the same. The router you can reach over here and here and here. Okay, we just configure on this router, on this router, on this router. So yeah, this one, conf D. And so IP route 192.168.1.128, and subnet mask is 255.255.182. And the next hop address would be this hop address, which is directly connected to this network. So we can mention the FA8/0 IP address, so which would be 10.0.4.1. And we'll do the same for other subnets. 64, let's do it for 64. Okay, for /64, you can take the route over here. Okay, we can mention the same 10.0.4.1 and 1.0, the last one. We can give this hop address interface address, which would be connecting directly to this network. So, which would be 10.0.1.1. So, configuration of static routes are completed. Now, the different subnets can communicate with each other. You can check even the IP routes or whether configured using the command show running config. There we go. So you can see it here. The routes are mentioned. And even you can check with the command show IP route. So see, it has a routes of 192.168.1.0, 64, and 128, which we discussed earlier. So now the router can transfer the packet if it is destined to this network, this network, this network, and because the route is existing in the router table. So let's check. Try to ping from all PCs. Okay, let's on the simulation side, it should be all successful. There we go. So That's how we will configure the static routes to make the different subnets to communicate with each other basically. So, how about if we have the complex topology? So, it's very hard to mention each static route for the network, right? So, that's where the OSPF would be step in. So, the OSPF is basically a link state routing protocol. Well, it is an interior gateway protocol which is used in single autonomous system, and it operates at layer 3 of the OSI layer. So, I'll just go through like how we will configure the OSPF. So in the router, on the config terminal, we just need to give the command router OSPF 1. Let's give it the OSPF ID 1. And we need to mention the connected networks basically, and also mentioning the passive interface which doesn't participate in the OSPF process. So first we'll just give the networks which are participating in the OSPF processes. We'll just give 192.168.1.0, and so we'll use the wildcard mask here, which would be for /26. It is okay, 255 minus 192, which would be the 63. So 63, and we also need to mention the area. That's it. And so only the connected networks we need to mention. 10 dot 10.0 dot 1.0 and 255 1.0. It's done, and we need to mention 3.0 as well. So 1.0 and 3.0 and this connector network. So that's how we will configure the networks in the OSPF. And we also need to give the passive interface, which is FACE 9/0. So that's it. So that's how we will configure the OSPF in the router. We'll do the same for this router OSPF 1 and network 192.168.1.64 0.0.63 area 0, and we need to mention 10 dot 0 dot 3 dot 0, which would be the subnet mask 255, sorry, the wildcard masks 3.0 and 2.0, and done. The same for the router 2, router OSPF 1 68 dot 1 dot 128 0 dot 63, which is of the area 0. And we'll also mention okay 10 dot 0 dot 4 dot 0 0 dot 0 dot 255 and area 0, and one leftover we need to mention is 2.0. We'll just change 4 to 2. So that's it. And for the router, for this router also the same. So first we need to go to the config terminal and router OSPF 1, and we'll just give the network, the connector network 192.168.192.0.0. The wildcard mask, which would be the 63, and area 0 dot 0 dot 1 dot 0 255 area 0 and 4.0. If you observe, we just have given the OSPF and the static routes as well, but it will prefer the static route over the OSPF because of the AD value, low AD value for the static route. So that's how we'll do the routing and the implementation and the subnetting in the Cisco packet tracer. Thank you.